Okay, let's talk about this. Balance the following chemical equations. You look at the board, you see this equation. This is zinc plus hydrogen chloride. We balance it. This is silver triazonitrate 5 or silver nitrate plus sodium chloride. And this is calcium triazocarbonate 4 decomposing. So let's look at how you balance this. These samples of equations will give you a guide how to balance other equations that are similar to it. Now let's start by defining what chemical equation is. A chemical equation is a symbolic representation of chemical reaction in the form of symbols and formula, wherein the reactant species are kept on the left-hand side, while the product species are at the right-hand side. So if we have A plus B giving us C plus D separated by an arrow, this side is called the reactant, this side is the product. Now, it is important that what you have at the reactant side must be equal to what you have at the product side. This is in line with a law known as law of conservation of matter that states that matter is conserved at the end of reaction, that matter is not destroyed or gained. You will not gain extra matter or lose any matter, it is conserved. So what you must do to balance equation, let's start from here. If you have this equation, zinc plus hydrogen chloride, what you have to do is this. There is what we call electropositive series. But you don't go about cramming all these things. Electropositive series, we have PS. So if you count from here, 1, 2, 3, 4, this is where hydrogen is. So this stands for potassium, this stands for sodium, this stands for calcium, this stands for magnesium, this stands for aluminium, this stands for zinc, this stands for iron, this stands for tin, this stands for lead, this stands for hydrogen. This stands for copper. This stands for mercury. This stands for silver. And this is gold. Now, this is going to help you to understand how you balance this equation or equations that look like this. Now, there is a rule that says that this is a metal, zinc metal. Now, when metals that are both hydrogen in the electrochemical series, this can also be referred to electrochemical series. We have electrochemical series have two types. We have electronegative series and electropositive. Because all of them are positive, that is why their baptismal name is also called electropositive series. Now, any metal that is above hydrogen, look at hydrogen here. Any metal that is above, that's from here, the metals that are from this way, when they see hydrogen in any compound, this is a compound of hydrogen chloride, they will displace it. What that means is this. If this zinc is above hydrogen, that is, if it is from here up, in this equation, what zinc will do is zinc will go and remove hydrogen from his wife. Hydrogen is having a relationship with chlorine, as you can see here. Zinc is more powerful because it is above it here. So it will say, hydrogen, what are you doing with this person? Go away. And now it now takes the place of hydrogen here. That's what happens. So you will now have, when that happens, you will now have this zinc taking place of hydrogen here. That means you will now have zinc and chlorine. The hydrogen, where is it? The hydrogen will be somewhere alone. Now, hydrogen does not exist like this. It's not stable like this. It exists as a molecular element. So it must be like this. This is how hydrogen exists. Now, since hydrogen exists like that, it means that you now have to check how many atoms of hydrogen are this product side now? It's 2. But at the reactant side, how many? Is 1. So that is where you have to balance it. Now, there's a rule that will guide you. If you're trying to make the number of hydrogen this side equal to this side, Don't put anything in between. Don't change. If there is 2 here, don't change it. The one you will change are the coefficients, the big ones. That means you can put 2 here. If you put 2 here, hydrogen is now 2 this side. Hydrogen is also 2 here. But you also check for other atoms or other elements. Zinc is 1 at this right-hand side. This side, zinc is 1. That means zinc is balanced. Chlorine is 2. This side, chlorine is not 2. Yes, chlorine is like this. And this is the right formula for zinc chloride. So the equation is balanced for this particular one. This is called zinc chloride plus hydrogen gas. Now, the next one now is silver nitrate plus sodium chloride. When silver nitrate reacts with sodium chloride, the same happens. This is a metal, sodium. This is also a metal, silver. Which of these metals is higher? So what will happen now is sodium. This is called double replacement. Sodium, we go and chase silver away. Why? Because sodium is above silver in the electrochemical series. Look at sodium. Look at silver. So because of that, sodium will say, silver, what are you doing with this nitrate? Go away, go away. Then it will take the place of silver. And this silver will now, because sodium will leave this chlorine, silver will now go and combine with chlorine. So if that happens, look at what it will become. The equation will become something like this. Remember, I said this will chase silver away to take the wife of silver. Then if that happens, you will now have sodium having the wife of silver, which is like this. And this is sodium nitrate plus sodium nitrate plus, now the silver will now take chlorine, silver chloride, silver chloride. Now, you check if this equation is balanced. Silver is 1 this side, silver is 1 this side. Nitrogen is 1, nitrogen is 1. Oxygen is 3, oxygen is 3. Sodium is 1, sodium is 1. Chlorine is 1, chlorine is 1. So this equation is balanced. Now, finally, look at this one. This is what we call decomposition. This kind of equation is called decomposition reaction. When it involves heat, when the decomposition is as a result of heat, it is called thermal decomposition. Notice this sign here is representing heat. Okay, now this is calcium triisocarbonate 4. All triisocarbonate 4s. What I mean by all triisocarbonate 4s, you can see magnesium triisocarbonate 4. You can even see sodium triisocarbonate 4, sodium triisocarbonate 4, and the rest of them, potassium triisocarbonate 4. We call them triisocarbonate 4s. But the name of the triisocarbonate 4 depends on which metal that is attaching to that triisocarbonate 4. So here, the metal here is calcium. That's why it is called calcium triisocarbonate 4. Now, these triisocarbonate 4s, apart from sodium and potassium, these other ones, when they decompose, when they receive heat, they decompose into their metallic oxide and carbon dioxide. That is to say, if calcium triisocarbonate 4 decomposes, it will form the metallic oxide. Which one is the metal here? Calcium. Which is to say, calcium oxide. That is the metal oxide there. And carbon dioxide. So if you have this at the back of your mind, you have balanced equation. That is to say, calcium oxide. That's metal oxide plus carbon dioxide. You know the formula of carbon dioxide, which is like this. The equation is finished. Now you compare. There's 1 calcium this side, 1 calcium this side. There's 3 oxygen this side, and 3 oxygen, 2 here plus 1 here. So this equation is balanced. So if you have any other equation you would like us to teach you how to balance it, please put it on the comment section. Ask me on the comment section, and then I will react to it. In our other subsequent classes, We are going to look into why these formulas are written like this. Why sometimes there are parentheses and all that. So please keep on following us. If you're not following us, follow us. Share the video, like the video, and put your comment section. Put your comment at the comment section there. It will help to encourage this page a lot. Thank you so much. See you next time.